All right, here's a question that is asking if I have 4.8 moles of sulfur trioxide, molecules, and then how many atoms will that be? Okay, so sulfur trioxide looks like this, SO3. So I have 1 mole of this. Now, when you look at a molecule, if I was sort of break it apart, it would have 1 mole of sulfur atoms. And guess how many moles of oxygen atoms? Yeah, there'd be 3 moles of oxygen atoms. So, 1 mole of sulfur trioxide molecule, that's a molecule, it would contain 1 mole of just the sulfur atoms and 3 moles of the oxygen atoms. Okay, so I have 3 moles of oxygen atoms. And now what I need to do is to convert that to how many oxygen atoms. Well, I guess I could say I have 3. I have, let's see, I start with 4.81. Instead of the 1 here, I could have put, maybe should have put the 4 there. Anyway, so I have, if I have 1 mole of this stuff, then I'm going to have 3 moles of oxygen atoms, but they actually started me with 4.81 moles of sulfur trioxide, so I have to times this one by 4.81 moles. 4.81 moles of sulfur trioxide. Okay, so if I multiply those two together, I don't know what that comes out to. It'll come up to a number. But then what I need to do is I need to multiply that by, and what this will be is moles of oxygen. And so then I'm going to multiply that by Avogadro's number. That's that big one that I gave you on the sheet. So 1 mole of any compound contains 6.022 times 10 to the 23rd atoms. In this case, atoms. You could use molecules or anything here, but in this case, we're using atoms. So I need to take this number here because there's 3 in the sulfur trioxide. There's 3 atoms of oxygen in each molecule of sulfur trioxide. Times that by how many moles they said we started with, and then multiply that by the 6.022 times 10 to the 23rd. Hopefully that helps with the question. It's a little bit confusing, that one, because typically we're just looking at moles of a whole substance rather than looking at the particular atoms inside that. Don't expect a question like that on a test. It's a good one though.